During the last class, we were discussing mainly about the various measurement techniques and measurement instruments and various measurement instruments and what are the factors regarding the case of measurements of regarding theories of tolerances and allowances. So that was the case. Now today we are going to discuss about mainly about fits and the various types of fits and the limits, everything. So in the case of system of limits and fits, it is also mainly a measurement. So we can say an assembly. It's mainly fit means a fit may be defined as a degree of tightness and looseness between two mating parts. I hope so you know. Okay, the mating part. So how do you refer this mating parts? Mating parts is the combination of two parts. When it is mated, it becomes one part for machines. So for all these mating parts, there are very important factors like tolerance, allowance, then various measurement techniques. So which we have studied in our previous classes. So in the case of tolerance and allowance, we were discussing about upper limit, lower limit. I hope so you remember. Like, what were the points which we were discussed in the case of tolerances and in the case of tolerances and allowances in the last class? Can any one of you say what were the points we have discussed under the case of theories of tolerance and allowances? Fateh, Mohammed Fateh, can you just list it out? What were the tolerances and allowances? Mohammed Fateh, are you available? Are you there? Mohammed
Yes,
Fateh, if you
sir.
don't, okay, can you just tell me the various fits or various types of fits, not the various types of fits, the
Yes,
various
sir.
measurements regarding the allowance and tolerances which we discussed in our previous classes. Do you remember this upper limit, lower limit, zero line, all that? Fateh, you remember?
Yes, sir. Yes.
Okay. Then what were the other points which we have described? What were the other points which we have described? You told me you remember. Can you just tell me the other points described? Other than the upper limit, lower limit, what all we have described? It was the zero line, the upper deviation, the allowance, everything. Okay, not an issue. So now today we are going to discuss about the various limits and fits. So in one word we can say a fit may be defined as the degree of tightness and looseness between two mating parts. Okay, that is a fit may be defined as the degree of tightness and looseness between two mating parts. Okay, that's the case of fit. A fit may be defined as the degree of tightness and looseness between two mating parts. So in the case of fits, mainly in the case of fits, okay, mainly in the case of fits, what happens is, mainly in the case of fits, what happens is an assembly is the result of a number of components fitted with each other. That is, we have an assembly which is the result, a number of components will be fitted with each other. So components must fit with each other in a desired way to ensure correct and reliable functioning of the machine. So what happens? In the case of fit, we may define as the degree of tightness and looseness between fitting parts. But as a result of number of components, because as a result of, there will be, in the case of fits, there will be various number of components fitted with each other. There will be various number of components fitted with each other. So the compound must fit with each other in a desired way. Okay, in exactly in a desired way. That's what desired way to ensure correct and reliable functioning of the machine. In order to ensure the correct and reliable functioning of the machine, we can say for an example. We can say for an example. We'll take example. Okay, for example, we have a shaft rotate in a hole. So automatically, what happens? In order the shaft for rotating in a hole, there should be enough clearance between the two to allow the oil film to be maintained for lubrication also. Okay, so what you can say, if you have a shaft automatically, okay, can anyone of you say by thinking about it an example? which you have studied before previously. Can anyone of you say an example regarding this for the fits? Rahul?
Sir,
We can say the to and fro of a piston movement inside a cylinder.
yes, sir.
There are so many examples. Okay, there are so many examples. That's what I'm saying. That's what I'm saying. Example. You remember the to and fro motion of a cylinder inside the piston. That's an example. For example, that's what I said. A shaft is to here. What we are saying example is against another example. Okay, a shaft is to rotate in a hole. In that case, the to and fro motion is taking place in the case of cylinder. But here we have a shaft rotating in a hole, and there should be enough clearance. And we will be always providing a lubricant oil in order to have a proper lubrication. So similarly, if the shaft is held tightly in the hole, there should be enough interference between the two. So as not to allow any relative movement between them. This is what happens in the case of limits and fits. Now, this is the main case with the fits. Now we can say about limits. What is the purpose of limits? Limits is the two extremely permissible sizes for any dimension are called limits. Okay. Mainly it is the two extremely sizes of any dimensions. Okay. That's what we say in the case of limits. Okay. It is mainly the two extremely permissible sizes for any dimensions are called mainly the limits. Okay. For any dimensions, the dimensions are not criteria, but it will be having two extremable. Okay, so it will be having the two extremable, that's two extremable permissible sizes for any type. Okay, for two extremable permissible sizes for any type. Okay, that's it. Two here. See, limits means the two extremable permissible sizes of any part between which the actual size should lie. This is what happens in the case of limits of size or limits. That is the two extremable permissible sizes for any dimension, that is maximum and minimum, are called limits. While deciding the limits for a particular dimension, okay, while deciding the limits for a particular dimension, there are certain factors to be considered, like the functional requirement of the component, the interchangeability, the production time and cost should be comparatively even compared to be minimum. These are the major factors we have to consider in the case of limits. So in limits also we have to tell that's the maximum limits of size and the minimum limit. This we have yesterday we already discussed, where the greater of the two limits of size and the smaller of the two limits of size is the maximum extent. This is what happens in the case of limits. So when we are saying about limits, the two extremely permissible sizes, okay, the two extremely permissible sizes for any dimensions, that is for any dimensions means you can have a variety of dimensions. That might be the permissible limit will be some, for example, we can say from 100 to 200. So the material can range from any dimensions, okay, to an extent. So what happens, the permissible limit will be 200 to 400. That's what we say. So what happens, it can range if any limits. That's what are called limits. So while deciding the limits for a particular dimensions, okay, mainly while deciding a limit for the particular dimension, okay, mainly for deciding the limits for a extremely for a particular dimensions, we have to consider the certain factors in order to have it is the educate for the proper placing of the equipment. So in order to have educate, like we should have the functional requirement of the component. Okay, we should have the functional requirement of the component. Then we have to discuss about the interchangeability. Okay, then we have to discuss about the interchangeability of the component. Then another very important factor is like the production time and cost to be limit. Okay, in order for having a mass production or low production, automatically as the product has to be sold or marketed. So what happens is the production time and cost to be comparatively minimum. That we have to make sure that this is the best way, or this might be the best way to make the material in time. Okay, so this is what happens. Like this is what happens when we can say example China, where they have a large production rate. So what happens? Their main achievement is they will be not having very precise, accurate dimension, heavy functionality products, but they will be having a replica product or the same product which will have almost the basic functions, At the same time, for doing this basic function, the production time and the cost will be not even 1/4 of the actual production cost. So what happens? All this, so the permissible limit all. But if you are doing in Japan or somewhere else, the permissible limit will be like 0.02 or 0.09 like that. But in the case of China, it is like 10, 20, 25 like that. So what happens is the functionality should not, it should not affect the functionality. That's what mainly, it should not affect the functionality. This is what happens in the case of limits. Okay, limits and fits. So in the case of fits, I was telling about an example that is the, you remember inside the cylinder size. Okay, then what happens? We have we can have the various size and nominals, everything. So in the case of this limit size, see, we are told shaft, hole, what is the purpose, everything we have discussed. Okay, now see, in the case of limit, we have two cases. You see, lower limit and upper limit. Okay, see, this is the lower limit and the upper limit, where there are two extremely permissible sizes. Okay, where I hope so you have drawn the figure yesterday. Okay, in the case of tolerances, this is the same thing. In tolerances, it is difference between the upper limit and the lower limit of dimension. But now we are discussing what do you mean by lower limit and upper limit. Okay, what do you mean by lower limit and upper limit? So in the case of lower limit or upper limit, there are two extreme permissible sizes for the dimension of the part. Okay, you can see there are two extremely permissible, which is permitted. Okay, permissible sizes of a dimension of a part, which is called upper limit. This is what happens. So there are two extremely permissible sizes for a dimension of the part, where the largest permissible size for dimension of the part is called the upper limit, and the smallest permissible dimension size of a dimension of the part is known as lower limit. This is what happens. Okay, so automatically what happens? So already the material should be ranging between the both. Okay, between the two or between them. The material should be ranging between them. That's what happens in the case of upper limit and lower limit. There are two extremely permissible sizes for a dimension. Okay, here we have two extremely permissible sizes for a dimension of the part. Okay, here we have two extremely permissible sizes for a dimension of a part, which is called upper limit, where the smallest size of the part is known as the lower limit. That's what happens. Okay, that's what the purpose is happening. So this is what happens in the case of upper limit and lower limit. Okay, so this is what, when we have the upper limit and lower limit, automatically, okay, when we have the upper limit and automatic of a lower limit, we will be discussing about the allowance and the allowance. We will be discussing about the allowances, the various allowances and tolerances. So that's what happens. So as you remember, there will be positive allowance and negative allowance. Yesterday we have discussed. Can any one of you say that's what's the difference between the possible positive allowance and negative allowance? Mohammad Asaf, can you tell me what is the difference between the negative allowance and positive allowance? Asaf?
Sir.
Yeah. Can you just describe me the difference between positive allowance and negative allowance?
No, sir. Arila.
Yesterday we have discussed regarding that shaft and everything. Okay, yesterday we have discussed regarding that shaft and other aspects. Yesterday we regarding the shaft and other aspects. Asaf, do you remember that shaft everything figure we have drawn?
Yes, sir.
Okay, so now we can say what happens is like, no problem. Like the lower limit is there. When the shaft size is less than the hole size, then the allowance is positive. And then when the shaft size is higher than the hole size, then the allowance is always negative. This is what happens. One more time. When the shaft size is less than the hole size, then the allowance is positive. Automatically, the shaft which has to be inserted in the hole, the size of the shaft is lesser than the hole size, then it is called as positive elements. And in some cases, due to dimensional or some other aspects, when the shaft size is becoming greater than the hole size, then the elements is called negative elements, which is almost to the same of the upper limit and lower limit. So always what should happen, it should stand between the upper limit and the lower limit in order for the purpose of serving the purpose. So all this. And when we compare this upper limit and lower limit, all this calculations are done with the help of a zero line. I hope so you remember, with the help of a zero line. Okay, for considering the upper limit, the lower limit, everything, we have a zero line. What do you mean by the zero line? It is the straight line corresponding to the basic size, while all the deviations, what are the changes or the deviations are measured from this line. So the positive and the negative, that's even the upper, lower, positive, negative, all deviations are shown, which is shown above and below. It is with respect to the zero line respectively. This is what the major factor. Okay, the major factor, zero line plays a very major factor in this case. What is the major factor that a zero line plays, especially in the case of mating parts? Can anyone of you tell me what you mean by mating part? Amit, can you tell me what you mean by mating parts? Amit? Amit?
Sir,
Okay. Amit, can you tell me what you mean by mating parts?
sir, അത് രണ്ട് ഒരു കണക്ഷൻ പോലെയുള്ള പാർട്സ് അല്ലേ സാർ?
Yeah, so we are manufacturing two parts regarding the tolerance, allowance, upper limit, lower limit with the deviations, and then we are trying to interconnect it, like the shaft
Yes,
and
sir.
the hole. We are trying to interconnect between the two holes, where the process after the connection, what happens? The product which has been manufactured for the purpose is completed, and its functionality is checked whether it is suitable for the function which is being designed and required. That's what. So in all these cases, tolerances, allowances, and the types of limits and fit all comes into the proper requirement. Okay, thank you, Amit. So this is what happens. So in this all these cases, the tolerances, upper deviation, all deviation happens. Then now we were discussing, okay, now we were discussing about the fits. Now the fits is, we mainly say our fits are of the two mating parts. Okay, mainly the fits are of the two mating parts. Okay, the fits are of mainly of the two mating parts. One second. We have told the fit may be defined as the degree of tightness and looseness between two mating parts. So that's just between the two mating parts. As the degree of tightness, looseness between two mating parts, there are various types of fit. There are various types of fit. It is only depending upon the what clearance and interference. Okay, there are various types of fits employed, but it is always depending upon the what it is always depending upon the between the two depends upon the size of clearance and inference. Okay, size of clearance and inference. So I hope so you have seen in so many cases we have clearance value and interference values. Okay, so what happens is, like in the case of fits, yesterday we told there are two mating parts, and the degree of tightness mainly loosens with the two mating parts. The according to the purpose, requirement, and functionality, the types of fit between the two mating parts depends upon the two factors. That is, one is the clearance and inference. So what do you mean by clearance? Can any one of you say? We have discussed yesterday. Can any one of you say what do you mean by clearance? Should I call someone? Okay, then I will call our Nisaq. Can you tell me what do you mean by clearance? Nisaq K.
Yes, sir.
Okay. Can you tell me what is by clearance?
Space അല്ലേ?
Base of
Space.
space. So mathematically, how can we say? We can here we are discussing an example with the shaft. Yesterday also we are discussing with the shaft. So today also I am doing with the same going with the same example. That's the shaft. So in the with respect to shaft, what will be there? With respect to shaft, what will be the actual setup?
Gap between two parts.
Okay. Again, okay, fine. But you can say it very clearly, like yesterday we have discussed, no problem. Any one of you is interested for saying an answer? Nivet, Fardeen, Fateh, Karthik Kotheri, anyone can say the answer? No. Okay, fine, no problem. So clearance, okay. So clearance, what do we clear? Clearance is the amount by okay. It is the amount by which the actual size of the shaft. Okay. I hope so. You remember, clearance is the amount by which the actual size of the shaft is less than the actual size of the hole. The actual size of the shaft is always less than the actual size of the hole. That's what happens in the case of clearance. Okay. The actual size of the shaft is less than the actual size of the hole. So it is the amount by which the actual size of the shaft, automatically the shaft will be having an actual size. So automatically the shaft is being inserted in the hole. So what happens is automatically what happens is the shaft is inserted in the hole. So the actual size of the shaft should be less than the actual. See, this is the shaft. So actual size of the hole. This is what happens. Actual size of the shaft should be always less than the actual size of the hole. That's what happens. Okay, that's what happens in the case of clearance. So where does the two factors come? The clearance and inference. Now we are doing the clearance and inference under which factor? Agilem. Now we are doing the clearance and which factor? Agilem.
Sir.
Now we are doing the clearance and which factor? With respect to?
Fit, alle.
With respect to fits. Okay. So what is the purpose? What is the purpose of a fit? What is the purpose of a fit? It is mainly used for mating of two parts, defined degree of tightness, everything. No problem. Okay. So now we come to clearance. So clearance is no problem. Okay. So Agil. So clearance is what? It is the amount by which the actual size of the shaft is less than the actual size of the hole. So in the case of clearance, we will be having two types of clearance. Can anyone of you say? We will be having two types of clearance. That is, one is maximum clearance and other one is minimum clearance. So when we are having maximum clearance, okay. So when we are having maximum clearance, what happens is this is the types of fit, which is going to be clearance fit. But before that, in the case of clearance, what happens is clearance is the amount by which the actual size of the shaft is less than the actual size of the hole in the assembly. Okay, so automatically the actual size of the shaft will be always less than the actual size of the whole assembly. This is, we can say, mathematically. We can say. Now we can say about the maximum clearance. That is upper limit of the hole minus lower limit of the shaft. That's the maximum clearance. Okay, that's the upper limit of the hole to maximum extent where the upper limit can be and to the lower limit of the hole. Then minimum clearance is the lower limit of the shaft to the upper limit of the minimum clearance is the lower limit of the hole to the upper limit of the shaft. This is what happens. Okay, so this is what happens in the case of clearance. And the case of inference, okay, inference, it is the amount by which the actual size of the shaft is larger than the actual size of the mating hole in an assembly. This is what happens in the case of a inference. Okay, so can you just have a differentiate? Can you just differentiate between clearance and inference? In the case of clearance, it is the amount by which the actual size, we will be having a shaft with an actual size which is less than, it will be always, the size of the shaft will be always less than the actual size of the hole in the assembly where the shaft is going to be inserted. So the size of the shaft will be always vice versa, the size of the shaft will be always less than the size of the hole in the assembly. Only then the shaft gets inserted. The example has been told in the case of a piston arrangement. Piston, okay, rack and on piston, okay, on the rack and piston, okay, the cylinder piston to and fro arrangement we can say. And in with that respect, we can say maximum clearance is equal to the upper limit of the hole minus lower limit of the shaft. Maximum clearance is the upper limit of the hole minus lower limit of the shaft. And the minimum clearance is the lower limit of the hole minus upper limit of the shaft. This is what happens in the case of clearance. Then we have the interference. Okay, in the case of interference, it is the amount by which the actual size of the shaft, it is always the amount, okay, it is actually the amount by which, it is mainly actually the amount by which the actual size of the shaft is larger than the actual size of the mating hole in an assembly. Okay, this is what happens in the case of interference, where it is the amount by which the actual size of the shaft is always larger than the actual size of the mating hole in an assembly. The actual size of the shaft is always larger than the actual size of the mating hole in the assembly. So here it was what? The actual size of the shaft was, in the case of clearance, it was less than the actual size of the hole in the assembly. Here it is the amount by which the actual size of the shaft, vice versa, is larger than the actual size of the mating hole in the assembly. Okay, the shaft hole will be maximum. Okay, that's what happens in the case of interference. Okay, then maximum interference and minimum interference. Okay, in the case of maximum interference, what happens is lower limit of the hole minus upper limit of the hole. It is the maximum interference is always the lower limit. It is mainly or always what happens, mainly or the lower limit of the hole. It is mainly the lower limit of the hole. Okay, so in the case of maximum interference, it is the lower limit of the hole minus upper limit of the hole. That's what happens. The lower limit of the hole minus upper limit of the hole, and the minimum inference is the upper limit of the hole minus lower limit of the shaft. Upper limit of the hole minus the lower limit of the shaft. That's what happens in the case of maximum interference and minimum interference. In the case of maximum interference is the always the lower limit of the hole minus the upper limit of the shaft, and in the case of minimum interference, it is the upper limit of the hole and the lower limit of the hole. Now, these are the various types of the limits and fits. Okay, so can any one of you say what is the purpose of these limits and fits? Anyone? As we are coming to the end of this session, so the question is, what is the difference between the fits and limits? What is the purpose of the fits and limits? Any one of you? Vishnu AP, can you tell me what do you understand from this?
Sir.
Yes, Vishnu. So today we were discussing about the limits and fits. So in the previous class we were discussing about the tolerance and allowances, where we are told the measurements. So it's a continuation. In measurements also we were discussing about the limits, the factors, the zero line, the shaft concentration, actual size, everything. So today we are discussing about the limits. So mainly the limits and fits mainly comes into application in the case of where? In the case of an, within one word you can say the answer.
Different tolerance for making
right?
parts.
So yeah, that's what it is the mating parts. We can say in one word, we can say assembly. Okay, assembly as a result of number of fitted components fitted to each other or fitted together to form a single part. That's what it's mainly the assembly. Okay, that's the mating parts. Okay, so all these factors which we have discussed about the fits and limits comes into the regarding the mating parts. So when the two parts are mating, okay, when mainly the two parts are making, there comes the exact the mathematical clearance values where the part should be fixed firmly, only then it will be suitable for the purpose or the requirement for which the product has been manufactured. Okay, for so that all the clearance values, the decimals, the points, everything should be precise. Okay, so in order to have a precise answer, we will be having various points, limits and fits, clearance, tolerance, upper limit, lower limit, all this. Why? Because in order to have a clearance, so if it's very small errors, like with an mathematically we can say 0.02 or 0.005, like small error occurs, it will be feasible, it will not affect on the, it will be not affecting on the what, it will be not affecting on the working of the product or on the requirement of the product. This is what happens. Now we will be discussing about the various types of fits. Okay, now we will be discussing about the various types of fits. So mainly we have the three types of fits, which is clearance fit, transition fit, and interference fit. Okay, mainly we have the three types of fit. Hope so you are noting down in your notebook. Mainly we will be having the three types of fits. One is the clearance fit, second one is the transition fit, third one is the interference fit. So as you know, okay, as you know, there are three types of fit, and we have already discussed what you mean by clearance, in interference, everything. In the case of, and you know what you mean by fit. So what happens now? You can have a several various types of fit. Okay, in the case of various types of fit. So we will start with the clearance fit. Okay, we will start with the clearance fit. Okay, so by looking the figure, okay, by looking the figure, what we can say, by looking the figure, automatically we can say this is the clearance. Okay, clearance, that is clearance is equal to clearance, which is equal to what, the hole minus the shaft. Okay, so the hole minus the shaft, that's what happens, the clearance fit. And hole minus shaft is always but greater than 0, the hole is greater than the shaft. Okay, see the hole will be always greater than the shaft. You can see over here, see the hole will be in just 3 points. You will understand the term where clearance is equal to hole minus shaft. So this is the hole minus the shaft. This is the hole minus shaft is always greater than 0. Okay, then hole is always greater than the shaft. See, this is the hole and this is the shaft, so it will be always greater. Okay, it will be always greater. And then in this we will be having a maximum clearance and minimum clearance. Okay, there will be, we will be having a maximum, we will be always having a maximum clearance and what happens, minimum clearance. So maximum clearance is what, so what happens in the maximum clearance from this line. Okay, this line to this line will be the maximum clearance. Okay, and this is what happens in the minimum clearance. So in the case of clearance fit, okay, in the case of clearance fit, okay, in the case of clearance fit, what happens, in the case of a clearance fit, there will be type of fit between an airspace or a clearance exists between the shaft and the hole. Okay, in the case of clearance fit, an airspace or a clearance exists between the shaft and the hole. Such fits gives loose joints. Such fits always gives a mainly loose joints. Okay, okay, such fits mainly gives a loose joints. Then a clearance fit has positive elements. That is, there is minimum positive clearance between the high limit of the shaft and the low limit of the hole, and it allows the rotation or sliding between the mating parts. So when we are saying rotation is, the shaft will be rotating inside the hole. Okay, like we can say what, like you can see in the lathe operation, the cylindrical components, what happens, the tool will be rotating inside the hole if you are drilling it, right? The same way, another example, if you are saying what, the shaft, the that is the allows the rotation, then the sliding between the mating parts. Sliding means what, always you remember, I hope so, the engine cylinders. Okay, mating parts, like the piston will be always going to and fro inside the engine cylinder, where the cylinder walls, inside between the cylinder walls, the pistons, with the help of piston and piston and connecting rod, what happens? The piston will be moving towards the to and fro movement. That is the example where we have a clearance fit. So in order to have a proper fit, we will be having what? In the piston, we will be having, sorry, oil rings. Oil rings. So what's the purpose of the oil ring? Oil ring is to supply oil to have free lubrication. So there is no wear and tear happening in the case of rubbing action, all that. So for that all we have clearance fit. This is the happens in the case. Okay. So we will continue in the next class as the fifth hour is of ours. We will continue in the next class. So keep an idea of it. Please note it down the 3-1. There are types of fits. It's a clearance fit and a transition fit, and we were discussing about the limits and fits. Okay. So I'm going to stop the class. Okay. Don't go anywhere. I'll just take the attendance by the meantime. Okay.